Hi everyone, welcome to the start of a new series. In this series we are looking at rates and ratios, and I'm working through the Maths Standard 2 syllabus from New South Wales in Australia, where I'm from. Now, going into this first video is mainly going to just be recapping some of the main concepts we learnt from rates in previous years and just making sure we are in a good spot before we move on to the new content. So, as we have talked about before, rates basically compare two different quantities. So thinking about some speed, for example, so let's look at example 1. We're looking at a speed which is 55,200 meters per hour. So this compares one quantity, meters, or measurement, to another quantity of time, the hours here. So this particular rate here, I want to convert this to meters per minute. So the first thing we're going to ask ourselves is, how can we get the quantity of hours to relate to minutes? Because we need these speaking the same language before we can actually go about making this unit conversion. So we're going to recall from what we did earlier in school that 1 hour is equivalent to 60 minutes. And with this in mind, we can write our rate on the left here, 55,200. Instead of meters per hour, I'm going to write this as meters per 60 minutes, because there are 60 minutes in 1 hour. And now, this is speaking the same language to this guy up here. Now we have two things, both in terms of minutes. And from here, we know that if we have 55,200 meters in 60 minutes, we want to figure out how many in 1 minute. So to get from 60 to 1, we can divide by 60. And we're going to do the same thing to this part of the rate, like we would doing things on both sides of an equation, for example. So once we divide this through, we're going to get 920 meters per minute. And just as a quick sense check, because sometimes it gets confusing whether we divide or multiply, thinking about it, our answer here should be less than this number here, because we're traveling a distance in a shorter amount of time. So we've gone from 60 minutes to 1 minute, so we expect we're going to travel a shorter distance. Okay, the next example here is we are looking at the unitary method, which we've looked at previously as well. So this question says that if a car travels 360 kilometers on 30 liters of petrol, we want to figure out how far it travels on 7 liters. Now, where the unitary method is really useful is that it's really hard for us to get straight from 30 down to 7. But we can use the number 1. That's what we mean by this unit, this unitary. We're just looking at a unit of 1. We can get any number into 1 by dividing it by itself, and we can make 1 into any number by multiplying it by 1. So this is where 1 is really, really useful here. So before we get to 7 liters, we want to do this a little in-between step. We want to get from 30 liters down to 1 liter by dividing by 30. And similarly, we're going to do this same thing with 360. So when we divide 360 by 30, we are going to get 12. So this means that we go 12 kilometers on 1 liter of petrol. And now from here, we can just multiply by 7. So we can multiply both sides of this by 7, and we get our answer, which is 84 kilometers on 7 liters, which is what the question asked from us in the first place. Okay, so moving on, let's try another question here. we're going to, once again, just practice using the unitary method. And we are working with this same rate manipulation as we had in this previous question. So, question 3, using the unitary method, we have that someone can type 70 words per minute. And we want to figure out how many words this person can type in 20 minutes. So, we want to get from 70 words per 1 minute into 20. So this one is actually not as hard as the previous one, because this minute, we have 1 minute, we just want to figure out how many words in 20 minutes. So since we're already at 1, we can just multiply by 20 to get to our equivalent rate for 20 minutes. So doing this, all we have to really do is multiply 70 by 20. That gives me 1,400 per 20 minutes. So it is very similar to the previous question. The only difference now is we were already given the rate to 70 words per 1 minute. So half of the unitary method was already done. We were sort of at this second last step in the previous question. Okay, so we're going to do one more, and we are going to be talking about one of the more well-known rates, and that is speed. Now, speed compares two quantities, distance and time. So speed can be written as distance per unit time, or in other words, distance divided by time. Because remember, rates are expressed as some quantity per one of another quantity. So the distance per 1 kilometer, 1 hour. So, for example, kilometers per hour. How many kilometers are we traveling in 1 hour? Now, this is an equation that relates speed, distance, and time. Now, since this is an equation, we can rearrange this equation. So, as long as we do something to both sides, we can move this around and set up another two different equations. We can make, for example, distance the subject by multiplying by time. So we can multiply both sides by time. So we can write this formula in another way. Now the distance is the subject of the equation. Distance can be given by speed multiplied by time. And we can also make time the subject of the equation. So we can get this thing on its own. We just need to get the speed away from this. So we can rearrange the equation by dividing both sides by whatever our speed is. This will give us time as the subject. So our time is going to be given by the distance on the left-hand side, which I know now is the right-hand side, so it's a little confusing. That is going to be divided by speed in order to find the time. So we have this formula here, and there are a few different ways to visualize this. One very common one is this triangle here. So if I draw up a triangle, that's a little wonky, but that's okay. So I have the distance up here and the speed and time. So this is like saying the distance on its own up here is equal to the speed times the time. So two operations are being done here. Another way to think about this is that speed is this distance, and you can see from this picture it is over the time. So speed equals distance divided by time. And we can also say that the time here is equal to the distance on top over the speed. So this is a way you guys can visualize this as well if you have trouble with manipulating the formulas like we've done up here. This triangle can be quite useful. Now, with all of that in mind, we are going to try our last couple of questions. So what are we up to? Question 4, I think. 3 or 4. We want to find the average speed of a car that travels 341 kilometers in 5 hours. So we recall that our speed equals the distance over the time. So substituting these values in, I have my distance and I have my time. My speed is going to be equal to 341 divided by 5, and that is going to give me a rate of kilometers per 1 hour. So rounded off, this gives me 68.2 kilometers per hour. Okay, our very last question. We want to find how long it will take a vehicle to travel 294 kilometers at speed 56 kilometers per hour. So this time our quantities given are the distance and the speed, and we are trying to find the time. So if we remember our formulas up here, we can get our time by taking our distance and dividing it by the speed. So I can write T is equal to D over S. Okay, so doing this now, we just substitute in the parts that we're given in the question into our formula. So we're given a distance and we're given a speed. So we can write our time as 294 divided by 56. And this is going to give us 5.25 hours. Now, 0.25 is like saying a quarter. So a quarter of an hour of 60 minutes is going to be 15 minutes. So you can leave your answer like this, or you can write 5 hours and you can write your minutes separately. This is like saying 5 hours and 15 minutes. So this is just a recap of all the tools you need to know before we go into more stuff on rates and ratios from this course. So rates just compare two different quantities, and they apply with speed, the unitary method we've done before, and a bunch of other things which will come up later.